So right now I will be doing the chapter 4 review discussion on chemical reactions. So first we know that there are 6 chemical reactions. The first chemical reaction is combustion, and that's when oxygen is a reactant and a product. So it would be like oxygen in the input and oxygen in the output as well. But combustion is mainly something that is bonded with oxygen. And then we also have single replacement reactions, which is when one element replaces the other, and the one that's the actively charged metal replaces the less reactive metal, or hydrogen in this case. So like for example, this would be if there was like magnesium and then we have like hydrogen chloride, and then the magnesium would change places with the hydrogen, and there'd be magnesium chloride and then hydrogen on its own. Then we also have double replacement, which is when, it's double replacement when a solid is formed. So if a solid is not formed, then it's not double replacement. And if group 1 elements aren't present, NO3 minus and NO4 plus is not present, then there will be a solid, because all those items are soluble, and without them then it will just be solid in its own, so there won't be any like liquids or anything like that. And we also have oxidation and reduction, which is when one value increases, like one is I believe increasing in oxygen, the other one's decreasing in oxygen, the other one is reducing. So hydrogen decreases the charge, so oxidation means the charge is going to increase, and reduction means the charge is going to decrease. So sometimes we might see an increase in oxygen and a decrease in another substance or something else. So like in this one right here, we have Fe plus O2 is Fe2O3. And the Fe is gaining oxygen and the O2 is losing oxygen in this case. And that's oxygen reduction. And then we also have reactions with alkali metals, and that's group 1 is is any alkali metals, and they react like vigorously with non-metals. So Na plus Cl would create NaCl, or sodium chloride. And then the alkali metals also react with water to produce a base and a hydrogen gas as well. So it's also an exothermic process, because we see that there's definitely a reaction with water in this case. And then there's also reactions of halogens, which is the group 7 elements, and that basically means they're salt forming elements, and they react with metals to produce metal halides. So like chloride plus 2 potassium would be 2 potassium chloride, or yeah. So also we talked about limiting reactants here, and we know that limiting reactants is anything that kind of limits the amount of product that can be made. So the compound which is less in quality and gets consumed faster is the reaction, because it just gets consumed up faster compared to everything else. There's no access. Everything else that's not consumed is called access. And we also have so an example of limiting reactions, if we have 3 cups of cheese, 2 peppers, 1 cup of sauce, and 5 mushrooms, and we have 6 cups of cheese, 6 peppers, 1 cup of sauce, and 15 mushrooms, then another limiting reaction would be 1 cup of sauce, because we can only make 1 pizza because we only have 1 sauce. But if, let's say, the values were to change and like the values are different, then there would be another form of limiting reaction. And also, when trying to figure out what the limiting reactant is between molecules, it's best to make sure that the 2 are balanced. So if you have 2 magnesiums and 1 oxygen, you'd have to divide whatever value you get for magnesium by 2 so that they can be balanced, so you can figure out which one's a limiting reactant. And for theoretical yield, it's the item that makes the least amount of substance, right? So that's that. And then to find the percentage yield, it's the actual yield, which is like, if they say we have 18 grams of carbon, then that's your actual yield. And the theoretical yield would be like if we have 75 grams of carbon. So you divide 18 by the 75 times 100, and that will give our percent yield. And the percent yield just describes how much we can make from the given substance here. And an example of that would be if we have CH4, that's 16.05 mass, and they said we are given well, you'd have to definitely, when you're finding theoretical yield, you first have to first balance the equation, then you want to convert to moles, figure out what the limiting reactant is, and then after you figure out the limiting reactant, you want to convert the limiting reactant to, convert the limiting reactant to grams of whatever substance that you're trying to get. So basically, it'd be like the mole times this would give us our theoretical yield, and then whatever grams that we have, like if they give us 23 grams, divide that by the theoretical yield that we get, times that by 100, and that will give us our percentage yield. And to figure out which is highly reactive, we don't forget that it also is both cells 3 and that depending on the cells, it will tell you like which substance is highly reactive and which one isn't, because we know that for the cells that are higher up, the electrons are held tighter together compared to when they're further down. There's always one electron that's prone to falling away or falling off from the given reaction, so it makes it highly reactive to losing an electron. Yes, and that's all for chapter 4.